Okay, where are we? All right. All right. So let's go read this test. Okay. All right, so what we're doing here is that we have a bunch of benchmark tests that do things like, well, they run a bunch of DDL queries and whatnot, which we've gotten off with things like Django. And we want to make sure that they don't do a crazy number of round trips, because we can lull ourselves into thinking that things work well in the case where everything is local, but then we have global deployments and the system tables turn out to be, well, really bad, because you have to make a global round trip and the speed of light is way slower than we want it to be. So we have this, this test file, this output file that I'm regenerating right now, that is supposed to track kind of expectations for these various subtests. And the problem with this approach is that it turned out to be pretty flaky. And the reason it was flaky is that one of the sources of variance is retries. And these retries happen just normally in transactional serializable databases. And we just need to be robust to them. And so what I care about is the count of round trips when there are no retries. And so that's what we're going to try to do, is we're going to try to detect when retries occur and then just rerun the benchmark iteration, clearing out the data. So we have this file, which is really about the validation, but what is going to be the source of our focus is the actual body of this, well, of this benchmark suite. And so the way this thing works is that it has a bunch of test cases, and there's some planning things, which we're going to try to track the KB requests, and then there are some, then we run the statements, or the statement, and we track that as well. And so the problem is, like, we need to know if we should throw away this run. Yeah. So first thing I'm doing is just regenerating this data, which I recall being very slow, and that's rather unfortunate. Well, and it's single-threaded in a certain sense. I guess I could try parallelizing it, or it actually does not seem to be very single-threaded. So it's running now. Well, we'll see how long this takes. That's, I think, also a valuable kind of data point. All right, so count KB batch requests in recording. This is really our bread and butter. What we want to do is figure out what happens when, well, we fail. Because we'll see that that is due to retries. I think this iteration cycle is too long. It's because this test.count is 50. Right. I made myself a help thing. Let me just put bogus stuff. Okay, it's time to rebuild. All right. So the way this works is that we pick a -1 value, we run the thing, and then we somewhere store this. Create database, set to 0. PC got reset. But this is interesting. Why would we run it n times and then only check this once, even though we reset this? Oh, it's per statement. Well, no. I'm confused. All right, so let's just try to run this thing. All right. So we're gonna instead run just pick one of them. So we're gonna pick I don't know, revoke roll. And then we're gonna also do bench time 1x just to run it once. And then I gotta get rid of my bogus flag. So in theory, this should be really fast. Theory, the keyword there. And indeed, okay, so we see 17 round trips. But what if I made this 2x? I don't think this does anything interesting for us. Maybe I don't want show logs. Probably pretty noisy. Okay, 17 round trips, but we did it twice. Again, looking back at this, validate this DDL analysis bench. We clear the counter every time. Why are we even running it n times? That just, it doesn't really help us. All right, count this. So I think at the end, what we want to do to introspect this is really peek into what these traces look like. B.report metric. Report metric is n units. The metric is per iteration. So by convention, this should end in per op. I mean, it's like effectively we're just throwing away n. It's like what's even the point? What if instead we did something like this isn't math. What is this? just a sync map. Okay. Does this make sense? Hopefully we still get 17, but now, oh, that's not what I wanted. I wanted this. So hopefully we still get 17 because it's still 17. And I want to get rid of short logs. But now at least we're like using b.n to mean something reasonable. Yeah, great, 17. All right, cool. So then we could think about something like 10x, and hopefully still the same, but at least now I know that it's like sampling, and the fact that these are floats is not crazy anymore. All right. So then the whole thing is like, what if we run this under stress or something? So let's try rewrite, but then just actually, let's just run our little test then without a rewrite. And then this also makes me think that actually we can I don't want to. Okay. 1x. So this runs all of the benchmarks. Is that what we want? Yes, it is. It's going to be kind of slow. All right. I wonder if we should have a subtest to filter this on which benchmarks to run. All right, so it's pretty quick. Good enough. Well, this is great. Things seem like they've gotten a lot better. Awesome. All right, so let's then try. That didn't take too long. It took about a minute. So we're going to try rewrite.start, but then there's another flag here, which is how many iterations. Rewrite iterations. And my rewrite iterations comes from this flag. So rewrite iterations. Let's go with 2. It'll take probably 2 minutes. In the meantime, we can look at this. So this got worse, much worse. This got better, a lot better. Mostly better. Some a bit worse. I think having this checked in is going to be really valuable. It'll make people cognizant of when they make pretty serious changes here. The validation stuff I think we did recently really probably cut this down quite a bit. But I'm curious to see where we got, where the negative results came from. In particular, these table introspection things. I guess in the meantime, I can just sort of run that. I don't think we're pushing this thing very hard. Okay, why do you have some expectations as ranges? Yeah, it's a good question. Why I did that. There were certain cases where I was seeing variability, and I'm trying to remember why I thought that that was just fine. I feel like there are some cases where explicit transactions, like where things are iffy with regards to whether you're gonna like hit certain optimizations from KB, but maybe that's not a good answer. And I think that's a good thing to dig into. I do recall when I first wrote this that it was totally the case that, I wonder if async jobs have something to do with it. Yeah, I mean, that's a great question. Like maybe should we just have one number and should it be deterministic, or should we have this range? I don't know the answer. It would actually be pretty cool if at the end we decide that it makes sense to just have a single number. And that's part of what I'm worried about now, is that I was seeing retries internally. I think depending on how leasing stuff happens, I suspect there are some cases where we'll, I don't know if we're ever going to be fully deterministic, but yeah. All right, so the thing that I think I'm going to add is a like v module log about these traces. I just want to see the traces. So we have, we're going through this recording and we are just looking at the parent span, and then we are count KB batch requests in span. Oh, it's just recursive. Okay, we're recursively calling this thing. And then we're just saying if the operation is this 16 chords and everything, then increment. Okay, that actually should deal with the optimizations related to splitting batches and all that. Could we do something that succeeds in placing jobs? Maybe. I'm not sure I necessarily follow what you mean by succeed soon around async jobs. Like the whole thing with this benchmark is, let's look at like how some of these are written. So these are written as like do a set of statements and then like execute some statement and count how many round trips this statement took. And so, I mean, we could retry until it meets the expectation, but I think the point is like, really understand what is the expectation bound, not like whether we'll hit some number, but whether we'll always hit some range of numbers. Yeah. So totally retrying makes sense, and like maybe that's like sort of sufficient. Is just take the minimum of a number of iterations, and that like maybe that's actually the right thing to do here, is just always take the minimum. But yeah, I don't know. I can see that. It's trying to be sort of cautious. All right. So what I said I was going to do is I'm going to do something like if log.v1. But then I would have to do show logs, which is going to be very loud. I'm gonna live with that. I'll live with that. Context background. Recording. And then we'll just do, oh, but I don't want this. I want it in the root because I really don't want it to get called recursively. And then we'll just do, in fact, we're just gonna do the whole recording because I think that thing has a nice stringer. All right, has my expectations thing finished? No, still no. Sad. Okay. So then we'll do. Okay. So we want to do something like Django. What's that? What's this text called again? ORM/Django. Django in lowercase. And then what we want to do is give ourselves a little v module equals DDL analysis bench. Bench equals 1. Now we'll show logs. And then I don't want any rewrite. That's not what we're doing anymore here. And then, yeah, sure, 10x is fine. Great. Seriously, what is this thing doing? In principle, this thing should have my trace, unless I messed something up. I'm realizing something. I turned off my syncing, so the code did not make it here, which is certainly part of our problem. Okay. So now it should. That actually explains a lot. Okay. All right. DL analysis bench. Did I not get this right? If.v1 recording was my thing. So recording. No. I am running the sync thing on a different. Yeah, sorry. I just turned that back on a different shell. I guess I can pull that into view. It did sync. At least I think it's synced. Okay. So why would this not? Look, let's just make sure we're not crazy. Let's just do it unconditionally. it's there. All right, my expectations failed due to a timeout because of course I didn't change that. Yikes. Yikes, yikes, yikes. All right. Okay, now we at least have recordings. I must have misspelled something. And so we see all of these ticks and chord send verbose. All right. We're doing some gets. I don't love the new log format, but that's a whole other thing. I wonder if we have a nice method to get this thing in the Jaeger format. That Jaeger format's pretty nice. I'm gonna look for just a second for that. I want that. I do want that, I think. Recording.to Jaeger JSON, yes. Sweet. And then we can actually look at these things. How do I want to do it? What is the best way to do it? Okay, I'm going to do some blasphemous things just to debug this for now. And I'm going to just open a file. Come on. Am I crazy? Yeah, that's the thing. And then, wait, maybe. Oh, it's a B. You know what? I don't even need that. Let's not even do this here. Let's instead just do this down inside here. Oh man. Come on. The streaming thing really, it takes a lot of CPU. I didn't think I needed a new computer until I started doing it. I'm on the wrong thing. So recording. This is a recording. Oh, this is r.to JSON. We'll give it an empty string. This may be more trouble than it's worth, but I'm hoping it's just going to pay off. Okay, so then we'll just do, I don't even care anymore. Now I guess I have the annoying problem. Wait. Man, it's so slow. I disabled under metamorphic. Right. Can't run make. Gotta run go test. Yes. Okay. And then I guess I want to care about 1x. And then this is all going to get sort of painful because I'm going to have to SCP back. In fact, let's do. Stop. What is it? Get CWD. That would also be a nice thing to do. Good trick, Yahor, thank you. This is making my IDE extremely slow. I like, come on. It's bad the extent to which I just like depend on this thing. I'm done with error checking for this hackery right now. We will add it back. All right, winter would require it anyway. And so now we should get at least something that I think will get synced back from the GC worker. So the goal here is that we have this testing framework that tracks the number of round trips that get made when we run these queries. And it's to make sure that like when we have global clusters that ORMs don't behave like super terribly. So these are queries that we've just like extracted from ORMs. And the problem is like we built this nice framework, but then it lets you get a point in time answer for what is this number, but it doesn't like prevent you from making regressions. So to deal with that, I wrote a perhaps big hammer of a test, which generates and then verifies the benchmark numbers against some expected ranges of numbers of round trips. The problem with that is that it turned out to be pretty flaky. And the reason is Cockroach deals with retries. Oh, so Richard, this is great. So Richard, you know about this framework. So I added this thing that like records the round trips and then it verifies as a test. And so the thing I want to do is make that not flaky and then maybe like fix some of these things. And so right now I'm just building myself tools to look at traces, in part to be able to detect the retries. So yeah, I think, there's a few other kind of nuances here. I may just end up injecting retries to make sure that I can be robust to it. It's flaky due to retries. So what I want to do is just like throw out iterations that involve retries. There are some other things that I hit, like we weren't actually using b.n for anything interesting. Okay. The other thing that I was just trying to do was I checked in that expectations file ages ago, but I never, it's gotten quite out of sync. I was hoping to regenerate it really cheaply. But that didn't seem to work out for me. So in principle, this should like go fast. In practice, it hasn't been. And now I'm doing this JSON thing. but I don't really care. And so we'll pay attention to that. All right, so I guess what I should show is that it flakes. And so to do that, what I really want to do is I'll just manually fill in a number. So we're back to this Django thing. And so I think we decided that the number on this one is 17. 17. All right, so let's make sure the test even works. And so we want to do that by setting the expectations to something other than 17, which I have a feeling it already is. And then I probably need to do something with subtests here. So how many tables? This is 8 tables to 17. So it thinks it's 2, and that seems not right. So we'll do that. And then the problem with my test, I think, is I don't have a good way to say, only validate that one. But maybe we can fix that. So this test, the way that it works is we come up here, and it's currently set to run all of them. So let's not do that. Let's instead only run some specific ones. So let's add ourselves a flag. And so the value, the default we'll just say is dot, and then this will be the regex of benchmarks to validate. Okay. So then this will just be plus star validate. That should do it. Okay, and then, yeah. I wonder if also we're going to want more output here. So we're hooked into standard in and standard out. In theory, we're logging some things. So now we want this, but then we want to not do rewrite, and we just want to do validate. And we want this to be, I don't know, ORM Django. Okay, so it is running tests, and it says it failed because it was looking for these, but it was happy with 10 and 13. All right, well, at least now we know it's fast, and that is good. One weird thing here is stress is going to get pretty strange because we're actually running this all as a subcommand. And we're doing that because it's not, I was having a hard time getting access to the benchmark results from within the same process. All right, so this all seems fine, but like let's go through them and just set these to what we now think they are. It's sort of bad that they've changed, and I wonder if we'll be able to do a bisection to figure out why they changed, because that seems like an important user story here. So wait, 1 table is 10, and 4 tables is 13, and 8 tables is, okay. So clearly we have an O of N situation going on, and I don't think we used to, and that is bad. So this alone, if it were on, would have like saved us, hopefully. Okay, so that's happy. So now what happens if I do something like, all right, so another thing is this thing is skipped under stress. But that is probably round trips benchmark. No. Sorry, validate. Let's get rid of that. And then we're going to do, what is this? We got the tags equal CRDB test off. We want this, but then we also wanted to do just validate ORM gender. All right. And in principle, this should like run a bunch of times, but then fail, because that's kind of the thing we're going for. If it succeeds for like lots of iterations, it's actually going to be sad. Although maybe it's just that some of these are flaky. And I vaguely remember the retries not being everywhere. Ah, right. Make test, but I wanted make stress. I guess I should pull up the original issue here. All right, it's passing a lot. That's sad. Okay. In particular, grant revoke. Grant revoke. Okay, so let's turn our attention then to grant revoke. And let's just run the test for a second. Let's see if we can make it work, and then we'll look at what's going on. Okay, so these are some wildly different numbers than we've seen before. Let's see if we can do this. I want this, but let's see if I can get the rewrite thing to work for me. Rewrite grants, rewrite iterations, 1, 2. Right? I think that should do it. The rewrite flag is the regex. All right, so we're running this with grant, and we're running it test count 2 and bench time 1x. That seems like it should be fast. We're just doing that a bunch. Okay, so now get diff. Right. I don't have git set up there. So grant revoke. Now it's 18, 24, 30, 16. Maybe this is stable now. Who's to say? So now that that's done, let's do it again, but stress. And then we're going to change this to gone. And then we're going to change this to validate. And then we'll see if this is still flaky. And if it's not flaky, then we'll just rewrite the things and push to CI and then go investigate why some of these are O then. I suppose another possibility here is more that just it wasn't. I remember uncovering it was due to retries at some point. I assume there's problem retries and reload. Okay. I said that. Clearly I said that. And yet, under load. All right. I think this is going to be more fun if I instead go to investigate some things. But I do want to set some benchmark expectations. Dot iterations. We're going to go with 2. We're going to see what happens. And then we're gonna figure out why Django query got so much worse. I think. Assuming it did. Assuming it did. Make sure this is actually running. Okay. Okay. I probably should have set test timeout higher. How many of these things really are there? Okay. Okay. So the other thing I was hoping to turn my attention to also was, well, the granting stuff, just also being O then. All right, so Django, table is 8. So PG add or def, PG type, PG namespace. So I think PG type is the source of our problem here. I'm just going to go out on a limb and guess. This PG attribute should be okay. I wonder if the index is actually what's hurting us. Okay, see, that was great. That didn't take that long. So are any of them not just one number? Seems like not even a little bit. Okay, okay. And that makes me kind of want to do this. And then just clean up some of this code before we dig into this and look at some traces. Okay. That's pretty annoying. Find as a friend. Okay. Well, see, this one seems okay. This one seems like maybe there's a little bit of variance here because we have split table at 2 values, and I can see that having off by 1. I'm not like super upset about that. Things were a lot worse before. Like, how bad does this get? I mean, part of me wonders, like, should I just like what if we run some more iterations? Does that do it? Not definitely. Two values. Oh, actually, in the rewrite, there already was some variance here. That's nice to see. That tells me this isn't a crazy concept, that the like splitting and unsplitting does affect things. And I wonder to what extent it affects things due to like, well, yeah, I don't exactly understand why, but it's actually great to see because it tells us this concept is sort of reasonable. All right, so then the whole thing is like, why is this getting shuffled? I feel like this was supposed to be sorted. Yeah, that is sorted. Okay, somebody else just was adding to the bottom. All right, so this is bad. And I feel like Ruffy even had something about this just the other day. Maybe he's already on it. No, I don't see anything new. Okay. I'm just going to assume he's not done anything about it. Syntax. One number is expected and then there is no range. Yeah. Yeah, I actually, yeah, we could do that. I don't know that this is that high overhead. I guess I'm still creating these JSON files, which are probably slowing everything down. is kind of funny. We don't know which one's which. I should stash that change. All right, so git status, git diff dash dash cached. Looks like there was some improvement. Yeah, it's O of n still. But like, what's interesting is it at some point was not O of n, and I don't think any of it should be O of n. It just means we're not using an internal lookup context somewhere, because in the context of all these things, we like have all of the range, like we have all of the descriptors already in memory, and so we're clearly doing it wrong. Richard, did you have a PR number for that improvement? Maybe it has context. Oh yeah, links become broken. Just put the number. So we run better to commit than not to commit. You can always five, 9, 8, 8, 0. PG table is visible. No, these functions that run queries, they're the worst. They're like not okay. So he thought he made it constant time, but did not. Okay, so how does this work? Descriptors.getImmutables. All right, so the problem is we haven't actually released any of these descriptors at this point. And so we don't want to use is table visible. We don't want to do this either. I mean, I guess we can. So this is actually a bigger thing that I've been thinking a lot about. We're in a built-in anyway. Okay, so then it's like if we've already leased this table, then there you go. But the whole thing is this is all part of a bigger join, and we have not leased. Oh, we should have leased these tables. Okay, so this should be an in-memory operation in principle. So then actually it's like interesting to look at what is the trace here. Okay, I wonder about this. So I have my crazy JSON thing, which was really crushing me under stress, but so ORM Django, validate, blah, blah, blah. This is good, but now I just want to test it. And before that, I want to clear all of this. But I also want to show logs. Wait, that was show logs. All right, so just bear with me. We're gonna do a little we're gonna do a dash v here. I don't know, maybe this should like be based on whether the outer test was dash v. We can come back to that. And then this logging thing here, we're just gonna make a print line. Five, 7, 9, 2, 4. All right, I will look at that. No, that didn't work. It did not work. Why did that not work? In principle, I should now be running. Man, it's so slow. I was hopeful. And then run benchmarks does. Oh, these are byte stop buffers. Okay. Okay, so 17 round trips, cool. Am I running Jaeger? I did get rid of my bash history intentionally. Okay, and then we want this one, let's say, well, kind of any of them. Nope. This Jaeger thing is awesome. Yehor brought up Dapper earlier. This is, I mean, Jaeger was like a straight up Dapper plan. Are you serious? Come on, computer. Don't explode. Please don't explode. Oh my god. Oh, nothing works, nothing works. The streaming thing really makes my computer just not work. I don't even know. Okay, maybe back. No, maybe not back. Mouse in, mouse. I should quit some things, maybe. Maybe better? Okay, maybe. I feel like I just crashed my window manager. That's fun. All right. just gonna press cancel there. I'm gonna hope that I can do this. No, fine. It's looking for a .json file. I think that's my problem. Okay. Sweet. Desk collection. Found descriptor 52. Cool. We're doing a namespace lookup. That's interesting. All right, let's go down the tree. So we know that 17 is ultimately the number that we're going to get to. So the question is, where are those 17 coming from? Materializers. So this is a whole SQL thing. Catalog KB. Catalog KB. Fetching descriptor. This is a bogus ID. This is wrong. This should not happen. Where? Why? How? That is not a real ID. That's something not right. So how is that happening? Okay, well this tells us something fun. Like, what in the world is this ID? Obviously, this is not going to find anything. Maybe we should just like repro all of this. Okay. Over here. We want to know why in the world we're doing lookups for just crazy IDs. So we want to do this. No. Yes. Seconds. Fun. All right. Okay, I need to extract this somewhere. We're going to create another misspelled bundle. No, I wanted all of the files. First of all, is this interesting? Not really. Not in PG Toast. That's fine. So we're calling this on everything, but that should be okay. And then local virtual table lookup join. I feel like we don't really want that here necessarily. Man, these lookup join things actually may be kind of working against us. All right. My guess is that is sort of what is going to kill us. So let's just look at the trace. Send cord sender coordinator send. So we're scanning the namespace table, the descriptor table. We're scanning the descriptor table. We are doing that some more. Okay, but now we're doing point lookups against it. We're just doing point lookups against the descriptor table, which obviously makes some sense. And we don't actually know particularly where, so. Yeah. All right, my guess is that this index is actually killing us. And this feels like a lot of these, a lot more than 8. Is table visible? Fetching all schema descriptors for ID. Is table visible? That seems bad. Is table visible? Is table visible? Found descriptor in collection. I mean, this is terrible. This is telling me that like this is somehow something much worse. Like, what is going on here? I mean, I guess I have a lot of stuff in this database, but this is bad. This is very bad. This like is telling me that actually it has nothing to do. Like it's like we're calling this table visible on way more stuff than we want to. Why would we be calling this table visible on any of this stuff? Because of this. E.g. table is visible. Yikes. Okay. C.OID, but C.OID could be some crazy stuff. And also, so like the filter, like this was really expensive, and so we would love to filter. We'd love to do this first. There's no guarantee that we even can. Huh. Okay. So how do we prevent this from being called? So PG catalog, PG toast. What even is PG toast? That's a whole other story. So and rel name equals target table. I feel like target table. Should this be here? This seems bogus. So if the first argument is false, so like this will always be false. Imagine that we should short circuit execution of and if the first argument is false. Yeah, we should definitely do that. That would be sweet. Do we not do that ever? I guess I can look at the query plan on this thing. I have that sitting around. Okay, so we have a hash join filter on this thing. Where's the call to the function? This thing. So this seems low in the plan. So we're scanning PG class, and then we're calling PG table is visible on OIDs. That is totally bogus. Like this thing is really expensive. Well, I mean, the optimizer is free to reorder those, and it doesn't really know on a certain level. Like, this is terrible. This is absolutely terrible. Because we're going to call this with every OID in PG class, right? Like, that's a lot of stuff. Select count OID from PG catalog.pg class. 141. We call is visible again. Oh yeah. I mean, I guess it assumes that this built-in is cheap, but this built-in is wildly expensive. Well, this built-in is particularly expensive in case that table doesn't exist. It's like actually very cheap. It's cheapish if the table exists, but it's very expensive if the table doesn't exist. I mean, like, what also are these OIDs? I feel like there's a trick here where we can just filter the OIDs. But I guess we can't, but maybe we can. I mean, so only these small ones are going to be real. But like, we don't have that really strongly enforced. And I mean, these are virtual tables. Like, right. So rel namespace, the OID, those are virtual tables. So like, we should definitely just say that you have access to those. But then PG type OID index is a hash. The index is all of these hashes. I don't even know if we avoid collisions there, whether we're just getting lucky. But I do know that nothing here is a table ID. Interesting to know. But like, this is not going to solve any problem. Like, PG class is like all of the indexes and tables and types. Or like, what is PG class? PG catalog. All right, so let's look. What did Jordan do here? 61211. No, that's unrelated. I believe. I'm pretty certain this is totally unrelated. This is about types. I believe. Well, yeah, I think so. so. Okay, so PG class table. I'm on my very slow editor. This thing is too slow to use. It's kind of upsetting. I mean, this is an interesting case where like some optimizer change led to a lookup join here, I think. Whereas before we didn't have a lookup join. We probably just did a full index scan. Probably I saw something fly by about like avoiding doing full table scans, but I wonder if it's totally destroying us here. PG class caps. Okay, PG catalog class OID index does not exist. Currently unimplemented. Okay, but maybe around here you can find. PG catalog. Class table. PG catalog. I think it's stupidly hard time getting this. There we go. Tables in relation like also incomplete. See. Okay. So this is func. Okay. Includes index entries. Make all relations virtual table with descriptor ID index ID. All right, I know about this thing. All right. I know about this thing. All right. So one at a time schema resolver. This thing's kind of unfortunate. Okay. Our problem is like there's a lot of stuff in here, and most of them we know are bogus, but we don't know that we know they are bogus. I think what we want to do is if we have all of the descriptors, we're going to build a hash map, and then we're going to see if we can just We need to solve this. All right. So let's do, this is good because this is where I was going before too long. All right, so what we're gonna do, which is a little bit crazy, is we're gonna do an all descriptors by ID map std.id how descriptor. Go to find users. We're gonna use this to like make a negative cache because we've already read all of the descriptors. So let's not be crazy and throw that all away. So when does this happen? Get all descriptors returns visible to this transaction. What's the second one? Second one is clear to me. Okay. So we're gonna do tc dot all descriptors by b equals 0. Okay, and then up here, I'm gonna say do.get ID. All right, so then, man, it just like sometimes under this much load, it doesn't even. All right, cool. And then we were in the built-ins, and we just want to like see what exactly that thing is doing. It's gonna be PG built-ins, isn't it? Okay. Cool. What? PG table is visible. Is table visible? Fine. Go to implementations. No, not so much. So slow. All right. Get immutable schema by ID. Look up table by ID. Okay. It's not great. In fact, this is hazardous. Okay. But the important thing here is I'm cool with all of this if this table exists, but I want to know if this table exists. And so to deal with that, I'm going to do something like in here, in here, in here, okay, so it's right here that I'm going to do like if tc dot all descriptors not equal nil if return nil catalog forward. All right, is this gonna just fix it for us? That would be cool. This seems sound. I guess the code should now be up there. So I just want test and I just want to validate Django. No, not stress, just test. This would be cool. This would be very cool. Heck yes. Do you see that? We went from 10 to 2. Okay, this seems like the obvious thing to do. No. That's just the corrupted buffer. Tmux and SSH and yeah, no, it was make test. I couldn't tell you why that happens sometimes, but I just know that that space is there. All right, so this is very exciting. So yeah, this is actually a very low risk change. I'm gonna need to write some tests for it at some point here, but I'm like pretty excited by the result to the point that I'm gonna rerun the expectations because it seems exciting. And then in the meantime, I'm gonna, I don't know, spruce up a commit message, see where I am. First of all, delete all of this stuff. I'm gonna delete my out files too. I need a better way to deal with that, but whatever. Git diff. All right, so the debugging stuff is not good. All the stuff in this test are kind of BS, but this collections change and that to do, that's gold. I love it. I love it when you can write, what is this? 10, 12 lines. Okay. I really should get rid of that whole thing. At least it tells me stuff is happening. What is even this function called? PG table is visible. I don't know if that's very good release note, but we're going to stick with it for the moment until a reviewer tells me it's bad. And then, okay, so git diff. No. Git diff. Gosh, this is hard to tell because I bet on GitHub it would look good, but Django, that was like 10 and all of that. Wait, why did it just delete the expectation statement? Right, So these Django things, all right, so somehow I broke this class. In general, I'm inclined to git stash all of that and then run it again. All right, I'm feeling like reasonably accomplished by this goal, though it was something that I was sort of thinking about doing unrelated to this. Anyway, I guess I'm disappointed that I didn't actually reproduce this flakiness per se. I'm going to have to let CI do that and then go dig into these traces a little bit more. But that doesn't seem too hard. I sort of knew what I was going to do there. This was a lot more fun. And hopefully we'll get some results in a second. I'm getting 100 something round trips to, I mean, I kind of want to really show this off. Let's get that built. And then I will run it on my local roach prod and show that that same query is all of a sudden not terrible. That would be the dream. I guess another interesting thing is, okay, so I was running 20.2.2. So it probably is a lot better now. Probably isn't 144 or whatever, but it, you know what, this doesn't work. Okay, so that's actually probably a fair criticism. All right, roach prod, roach local, roach prod, stage, roach, local. 15 milliseconds, 10 milliseconds, all that. Still want the explain analyze on this. Maybe this actually wasn't so bad, but we do see, yeah, point lookups all over the place. Which is not. We see, I mean, there's like one table here, so we know that we should see like 10 or something. Yeah, these are just OIDs. These are like not real descriptors. And so this negative cache is going to save us. So roach prod stop local. Is my syncing done now? Cool. Well, would you look at that? I'm content. I'm ready to declare success on this stream because this really is a simple, not very controversial change that just makes a lot of sense and is actually probably going to have the outsized impacts beyond just this specific thing. And then while we're at it, I mean, I guess it just fixed that query, but you know, people use Django, and so that's good for Django. Cool. I'm gonna sign off, but I think I had fun. I hope you guys had fun. Maybe not exactly what I had intended to do, but I think we made something important. All right. See you all next time.